Hey everybody, I'm Josh. So we have a very interesting panel. We're going to talk a little bit about, as Evan said, how we might get AR past kind of hold your phone up, look at a space, see a hot dog dancing around, and to something, whatever the next step is. There's some creative questions there and also some technical ones. So we have, as Evan mentioned, we have Serge Belongie from Cornell. We have Ryan Measel from Fantasmo. We have Mandy Mandelstein from Luxloop and Jeff McConaughey from 60 AI. So we're going to talk a little bit about kind of how everybody fits in. But I did just kind of want to start with sort of the basic question is, now we're seeing augmented reality as it has been for, 5 years, 10 years, right on the cusp of taking off. Everyone has these phones. There's a lot of potential, and we're ready to go. So, but I want, and anyone please take this, like what's the big technical step in the near term that kind of gets us going? And whoever wants to step in, please take it away. Ryan?
So I think where AR is at right now, to go beyond kind of this localized experience where I'm placing content relative to a user, and you want to move out into the world. You want to place content at a location or relative to certain objects. So this is very similar to these kind of poster experiences where we want to go out into the world and have content that we discover. And to do that, you need to be able to localize very well. And I think that answering that question of where am I is really that first step that's going to allow AR to move past just the user and the device.
And when you say where am I, is that something more than using GPS or something akin to that to kind of locate me in, on 23rd and 8th Ave, for instance?
Yes, absolutely. So when you have cameras and you're able to map your space, you can move beyond, kind of GPS and these other RF sensors and other localization solutions to camera-based localization solutions, which bring the accuracy down to centimeters and also give you orientation too. And that's that component that allows you to accurately place content relative to a user.
And part of that is not just only understanding your own location, but looking through the camera and seeing and understanding the space you're in. There's chairs here. There's a wall in the back. And that's an interesting mapping challenge. I'm not sure if mapping is exactly the right word, but that's sort of what you're working on, Jeff, at 60 AI. Can you talk a little bit about how you see that technical challenge?
Yeah, I think what we think is really important is for people to be able to engage with their environment. And that's one of the reasons that we don't think that consumers, when they see some of these apps, they've said kind of meh, because it doesn't feel real. It doesn't feel like you're part of the environment. So what you're talking about is occlusion and being able to have your Pokemon, if it's hiding behind that chair over there, it's actually hiding behind that chair and it can pop out and surprise you and it feels comfortable and it feels like something you would expect in that environment. And so a lot of what we're working on is how do we create that at scale where we can actually have multiple people scanning an environment at the same time and combine all of those assets together in the cloud so that we can have a true multi-user experience where people can see all these things in real time.
Yeah, and so that would involve, I have to be able to look through my phone and understand the world in the same way that you, looking through your phone, understand the same world at the same time, so that you're seeing, for instance, that hot dog from a slightly different angle. That's basically what we're getting at here?
Yeah. So it's, I guess Evan said he wanted to go a little bit technical. So what we're doing is we're able to combine sparse maps to figure out, key feature points at a pretty broad angle. So you could have your phone turned on over there, someone else can have their phone turned on over there. You're maybe 50, 70 degrees apart, and we can determine that you're still in the same mapping area and put you into the same universal coordinate system, which is important because if I see something and you see it move in a different way, or if it doesn't move at the same pace, it doesn't feel right. And so the key thing is to combine these through relocalization to put people into the same coordinate system.
And is where we end up here, we saw this revolution with mapping where Google, and I mean some other firms as well, but really Google has taken the lead on this, is basically building a digital understanding of the entire world that's like a single thing, like a map that extends across everything. Is this a matter of just adding extra dimensions to that map? And if so, that seems like a tough challenge given the dimensions change constantly.
Yeah, it's we like to think of it as you could store this room in memory on a phone. If you wanted to store this room and the block outside, you could store it probably on the disk on your phone. But when you get beyond that and you have something where you actually want to interact with your environment, we think the cloud is what's absolutely necessary to make this into a real user experience. So we're working on ways to actually, if you think about Google Maps, you don't download the whole US when you want to just get from 23rd Street down to 45th Street or something. You download just what you need just in time, and it gets streamed out to your device. So we're working on ways to do that with meshes so that we can actually have, think about tiles of meshes where we can recombine them just in time on the device, store them in the cloud, and then you can share them with other people so that if one person has scanned this area, you benefit because you can now take in the mesh information that they had brought in so that you can get really good occlusion. So you're walking down the street and we know that there's a tree there and we can, I keep saying Pokemon just because I love Niantic, but we can already know that there's a tree up in the distance, and if there's a developer who's building an app, we can put those objects back behind those and show proper occlusion.
I think there's another, in talking to people about this, there's another concept that's come up. For me, it was new. I mean, I'm obviously not quite as deep into this as you guys are. And Serge, I was hoping you could talk a little bit about this. What are we talking about when we talk about persistence in AR, and why is that so important?
Sure. I think, both Ryan and Jeff touched on that indirectly, that if we're all experiencing augmented reality through personal devices, it could be a headset, could be mobile, phone, and that exists in the cloud or it exists in a mesh network or something, we all are familiar with the concept of lag, so we don't want lag with respect to the objects being tracked. But then there's just the idea that you found these great features to track, you're using advanced SLAM methods like what Matt was talking about, and then something distracts your attention, you turn away, and then you go back and you want it to snap right back onto that. It could be your selfie lens, it could be a dancing hot dog on top of a table, but you just need to know that it will be there when you look back, and that will also be the case for all the other people that are participating in that AR experience.
And you want it to be there when you look back, or you want it to be there when you leave and come back 4 days later and pick up whatever it is you left?
Maybe, I don't have a
Okay, well, I think, Mandy, actually, this would be a great time for you to weigh in. You build on top of these platforms and have a good sense of, creatively how the technology either enables or limits the actual application. So tell us a little bit about how you think about these and just kind of like what technologically you really want to see so that you can go out and build something that you've got in your mind right now.
Yeah, certainly. So we've been building creative applications sort of on this idea of an AR cloud for a couple of years now. Really with what tech was available, and it's really exciting to see how quickly that's advanced. We started as filmmakers, and we were really interested in what would a film that lived in the world look like, and I think it's really powerful as a storyteller to know where someone is and be able to tell a story that serves those needs. So knowing where someone is, knowing what the weather is. We did an application for a museum that allowed people to eavesdrop on some fictional characters, and at the time we were using beacon technology. And looking at the limitations of that, knowing we could get room scale awareness really well, but not having precise accuracy, but knowing that application of the tech would allow for that. And so we really look at the limits and try to hide that in the content from a creative perspective. We're really excited about the AR cloud and just being able to do some of these implementations at a larger scale and being able to not necessarily have to go in and build a sensor network to detect where someone is really accurately.
Okay, talk a little bit more about that museum application. I thought it was a really cool idea and an example of how you don't necessarily need to get, to some futuristic technological space before you start making things that are really impactful.
Yeah, I mean, the idea started, we were looking at different tech, and we're really excited about everyone having phones and what that could enable in the real world. We saw a lot of people being focused on screens and being at home. Everyone's on Facebook. How could we use this technology to get people back into spaces and interacting? As creators, we found ourselves going to museums and eavesdropping on people's conversations. We looked at things like Sleep No More and their popularity, and how could we take that to a cultural institution and have it exist without the need for actors and the overhead of the theater. So we went in and we did a bunch of research. We got a grant to do this project with the Minneapolis Institute of Art. We scripted about 90 minutes of content into the space. We also like to focus on the user's point of view and who's adopting this, and how do we use these tools to blend into the experiences they're already having. And I think from a user perspective, they don't care as much about the tech, and the tech's really important to figure that out to deliver these experiences. But if you can't get it into the user's hands, if they don't have a reason to download it, none of this is ever going to take off. And I think we need both sides of the spectrum for these things to be delivered. For this cloud to become robust, we need people to use it. It needs to get built. So I think we really need to keep both sides of this equation moving forward.
Right, and you're basically building in a medium that doesn't have a language or the guardrails that, you said you come from film. There's just certain conventions about film. How much of a challenge is that there's not conventions around, putting beacons around a museum and deciding how people experience that space through some sort of AR experience. Is that limiting? Is that expanding? Is it both?
I think it's totally expanding. It's a total transformation on how we think about creating media and how it lives in the world. We've lived flat for hundreds of years now, from print to poster to video, and even on screens and mobile devices, it's still a screen-based thing. And we're moving towards this idea of having volumetric content and it living in space and somebody moving through it to experience it. And it's totally revolutionizing how we have to think about how this content is made and what's possible.
So there's a couple different ways now, I think, that there's basically two different ways that people are thinking about experiencing augmented reality. It's either through a phone in some way or through a head-mounted device. There's the HoloLens. Soon there will be the Magic Leap. There's Oculus doing VR and things like that. Serge, how much is what we're going to see in the near term really going to be focused on the phone with the head-mounted displays kind of further out, or is that even a false distinction?
Sure, and let me add projective to that mix.
Okay.
So let's just look
Noted.
at these different options. You've got projective AR, you've got the headsets, and then mobile handset or tablet. I think the one that captured our imaginations the most probably is the headset. There's so much science fiction, there's concept videos going back decades showing this kind of thing. And there are so many barriers that lay ahead to make that happen. In my opinion, the headset has to reach a point of around 50 grams before you're going to put it on your face. I don't know what the current weight of these headsets are. Your glasses are probably maybe 40 grams. But that's just a rule of thumb. Let's say it's got to be less than 50 grams. Then you've got the number of focal planes that you're dealing with. I think that the eye tracking technology is extremely advanced, but in order to produce the right depth of field, you need to be convincing about focusing on a point, making it sharp, and having the other parts look blurry in a realistic way. So getting a number of quantized focal planes is a challenge.
What do we see with with the HoloLens in terms of focal planes?
In HoloLens, I don't know. So I'm sure the Microsoft people here can say more about that. The Magic Leap one, I'm not sure. I think there's just rumors that it has maybe 6 or 7, and these are log linearly spaced away from your eye. And that will get better. It'll look more realistic. But then there's this field of view problem. And my issue with the field of view is that, just to take an example like Minecraft, we all see these articles where, like tech articles, and there's a feature image that shows people standing around a table, and there's this beautiful, immersive Minecraft environment. Or someone is designing an airfoil and they have the headset on and they're showing this incredible visualization. The problem is that picture taken from a third-person perspective is 10 times cooler than what you see when you put the GD headset on your face. All right, that is the problem. You're wearing this thing, and it's like it's cool for like a second, but the field of view is so small.
And when you say the field of view, that means that like I see from like all the way over here to all the way over here, but I can only actually see like this much.
Oh, it's a strip. And don't get me wrong, this is impressive that this is possible. Okay, but it's like you map out the room, you run the advanced SLAM algorithms, but the field of view is just still so small. And I don't know offhand what the field of view would be through a pair of ski goggles, but it's pretty big. It's cutting off some of your peripheral vision, but we need to get the field of view at least that big. And this is something where projective has a big advantage, but with projective, you get the washout with the bright lights, you don't get the parallax. But let me just take a very contrarian position here that it is not the hardware that is holding us back. It's not really any technology holding us back. It's that the field went in the wrong direction. And this is my beef with hot dogs. This is why I brought this up with Evan in setting up the panel, is that something went wrong with AR. And I don't know when it happened, let's say maybe 25 years ago, I don't know. Look, just for comparison, look at graphical user interfaces on modern computers. Every computer has a mouse or a touchpad. And when you move on that mouse, you have a cursor, right? A pointer. The pointer is usually a little arrowhead, and it has been that way for something like 40 years. Some people here use computers before there were pointers, and it was just a cursor. I'm not going to make you raise your hands, but there was a time when it was just a little flashing cursor, and that was how you programmed. And then at some point, the GUI popped up, and you got a pointer. And that pointer has stayed basically the same for 40 years. Now, in the 90s, there was some weird shit that happened where it changed into some animated stuff, but that was gone, and we're back to just having a pointer. And nobody complains that the pointer isn't fancy. It just tells you where you are on the screen. You need to be able to move the pointer and click on something unambiguously, right? The question for us is, why did that not happen in AR? Why did we feel compelled as a field, myself included, to skip to the dancing hot dog, the splashing whale, the immersive hyper reality nightmare of like ads hitting you why did we skip the part where we just figured out how to put a dot on something in the scene? These devices in our pockets are very well engineered. They have outstanding screens, fantastically responsive touch displays. I don't think they're going anywhere anytime soon. I think a lot of AR content is still going to come through these devices. But when I think about helping my mom with her computer remotely, and I just wish I could put a dot on the keyboard, hit this key, right? I just want to be able to do that. That takes like 1960s level laser technology, 5 milliwatt laser. This would be 20 cents to make this. If I could just put that dot there and then it's clear. I don't want her to put the headset on. You know what I mean? So clearly I have some strong opinions about this, but I just think we skipped the part with the pointer. So let's get that part working first. And it comes as no surprise. My research group is working on this. But I just think that is something that we skipped. And then it makes all the other stuff, the dancing hot dogs and stuff, it just looks so gimmicky because we didn't deliver that core value of just being able to indicate unambiguously some point. It doesn't need to be a little fox you're chasing, or it's just a dot. Get that part right, and you can't hide behind any of the other graphics. You just solve the SLAM problem, use the IMUs, get all that stuff right, and then we deserve to do all the immersive stuff and the dancing hot dogs. That's my piece.
I'm wondering what other people think about that. Have we gotten ahead of ourselves?
But what does that pointer enable? If there's nothing to click on, what's the point? Like, why do you need it? There needs to be a reason for someone to need that. A computer allows you to access all this other information, games, websites. It can be useful or not useful, but if there's nothing to do with the pointer, what's the point of having it?
I think 3D is it's a different paradigm. So like we had cavemen use stone tablets and they wrote on those, and then we had paper and people wrote on that, and then we had websites which people made look like paper for a while, and then that started to get more dynamic. And I think it's just we need to figure out what's the right use case. One of the things that we've been focused on is working with a large spectrum of developers that are, artists, they're game makers, they're working in industrial applications, and what we found is nobody really understands the right paradigm for consumers to adopt AR. And so we're taking the approach of, we don't want to try to cast out how we think AR should be. We want to work with them to feel out what feels right, and then figure out a way to make that into a reality. But it's a really hard problem, and it's not something that instinctually I think humans get.
Yeah, I think too the hot dog is to distract that the technology isn't there yet. So like if I have a pointer but I don't know where I am or I don't know what's around me, does it really make sense to point? I know, so Fantasmo, our background was building AR content, and one of the issues that we'd run into is, our tracking's not good, our occlusion's not good. So what's the answer? I'm going to put some effects, I'm going to put some models, and if they slide around a little bit, it's okay because they're dancing, right? If my pointer slides around, that's just not that useful to anyone, and then the utility's gone, right? So I think there's these underlying technical issues. It's the localization aspect, it's the mapping aspect, and then it's interoperability. So if I have an HMD or I have a mobile device, how are they sharing a map? How are they coordinating the same space? So you see, Google recently announced their VPS platform coming into Maps. While this is...
And just quickly say what the VPS platform...
Oh, yeah,
what that
sure.
means.
So the VPS from Google is their visual positioning system. So this is a camera-based solution for positioning outdoors in conjunction with their maps. It was actually an extension of kind of where they started with their Google Tango project, which was around computer-based vision, localization, and mapping. And this is a way that you can get very hyper-accurate positioning just by taking an image wherever you might be if you're inside of a mapped area. This is great if you're on a Google platform. What if you're on a Microsoft HMD? What if you're a robotics startup? What does that mean for you? Can you even access that map, right? So this layer of mapping that we're building right now, that a lot of people are trying to build. There's the big guys are trying to build it. There's startups that are trying to build it. Who owns this map data, and how is that map data shared? Because ultimately, the only people that are going to say that, oh, it's great that if Google owns this whole map is somebody that works for Google, right? So for the rest of us that are trying to enable these different experiences, we're trying to build applications on top of this. The map just has to work, right? The map is this layer. It's a protocol. It's a data set. It's the internet of the real world, right? So it's I don't care how SMTP works. I just want to send an email. In the same way that I don't care how the maps, I don't care how the tracking works. I just want to build my navigation experience. I want to build my pointer. Whatever that happens to be, those standards need to be there. The interoperability of the data needs to be there.
Ryan's right about that. I think if in what I described that's so focused on this pointer concept, it lays bare so many of these technical challenges. And if you can't hide behind the fancy graphics, there's nothing but trying to solve this multi-view geometry, pose tracking, pose estimation. All those problems suddenly are the most important thing. And so I think the notion of a DNS in the setting of AR is critical. Everything this panel is talking about is super important. I just think that if you take it, I just want us to check our assumptions and see if our instincts might have been wrong. If we take the setting of food preparation, think about the future of Blue Apron and meal kit preparation. Our instincts probably would say that the AR future of meal prep would be something where you put on an HMD or you have a projector thing over your kitchen island, and you then lay out the ingredients, and you get this sort of little chef like pointing to the cucumber and all these steps and stuff. And I would agree that that kind of thing is cool, but that's just not how it happens today when you have human interaction. You have someone, it's actually a lot of voice. You have someone explaining things to you. And the one thing that's missing with a voice assistant, there's several popular voice assistants, is just the ability to point to something. So I think if, like what Ryan was saying, you can't recognize, I'm talking about something at a small scale, it could be at the urban scale, but if you're not doing a good job at doing the object localization and pose estimation, you're going to be pointing to the wrong thing. And so what I'd like us to do is I'm completely editorializing here, but I just think that we should just get rid of all the graphics for a little while and just say, let's pick some tasks and actually use existing technology. It could be your phone, it could be a voice assistant, and just add that little epsilon, that one thing that allows the technology to reach out and point to the cucumber, point to the garnish, whatever it is, because that's the only thing that's missing. And then if you deliver that value in the context of Blue Apron, and then you do A/B tests with focus groups and you say, now, do you want the one that's minimal, that just has the pointer, or do you want the little pudgy dancing chef that's dancing around? If it turns out people like all the bells and whistles, cool. At that point, we can say that is an option. But what I think Ryan put his finger on it, that if you strip away all of the fancy graphics, you're only left with these fundamental perception and projection and display problems, localization and so on. And that's something I would relish if our field had to just return to its fundamentals in that regard.
Do you think that part of the problem here was that people who are building, who are thinking about augmented reality, didn't have a completely clear sense of what it was going to be for, and so you went for a use case that would be attention grabbing, even if it wasn't sort of systematically building up the tech that you would need to get to a sort of mature ecosystem?
I think you see across a lot of industries that when you have emerging fields, it's toys, right? People's first thought is always like, what game can I build with this? What kind of entertainment experience can I get out of this? And it's only like via dog fooding the technology on those kind of use cases that you get it robust enough that then you can push for these really utility applications. So like, kind of where we're at right now, this is a panel about augmented reality, right? But we're talking about an AR cloud, and that's kind of like what the discussion is in the industry right now. But these maps are the same maps that you're going to use for autonomous robotics. It's the same maps you're going to use for disaster relief. Same maps you're going to use for accessibility. And this is just I'm keep hitting on this, but this interoperability aspect is the key to underlying all this. And so that's part of what Fantasmo, what we're trying to enable through pushing for first-party data ownership, open standards around data formats, interchange, messaging, and trying to provide a platform for that.
And just to be clear, so what you're talking about here is the potential development, not of like a single standard for augmented reality where it doesn't matter what device I'm using, what platform I'm seeing. If I go into a space that has some sort of tags or augmented reality aspects, we'll all see the same thing. It'll be like one augmented world for Microsoft and another one for Apple, and those things will not be able to connect to one another no matter what.
Sure. I mean, I think it's these aspect of layers on the world, right? So whether it's a physical layer, like I might care about, how many seats are in this auditorium, or I might care about how many Pokemon are in the auditorium, right? And that's a different layer of my application. And it's probably a different layer if I'm the developer of that game or an architect of that specific platform.
The one thing that we all talked briefly before this panel, and one thing that we talked about a lot in these conversations, which hasn't come up now, is as you're mapping the world, especially as you're mapping a space like this, which is not public, is privacy and data control. And it does seem like that is a big sort of unrealized challenge so far about how, what are the standards and how we think about this. And I think we should talk about that for a little bit. We have about 5 minutes left, and we'd just love to get your thoughts. And Jeff, maybe if you want to kick off, like what are the unique privacy concerns when it comes to doing this kind of AR mapping and so on?
Yeah, so I think one of the key things that for our company, for 60, was we sat down, one of our first big company meetings. We're a startup, so we're not that big, but we wanted to talk about privacy and what we stood for and how we wanted to move forward. And we talked about transparency, and we want to make sure that whatever we do in the future, it's very clear for other people to understand what we're doing with their data and to allow them to have control over what that data is. But what's interesting is, as we've worked with developers, so we have an SDK that any developer can use, and it kind of solves a lot of the problems that Serge was talking about. It gets down to just the basics of where's the pose and multiplayer and those types of things. There's different layers to the data that we push. There's sparse maps, which that doesn't really contain personal identifying information. There's textures, which are more photorealistic, and then in the middle there's meshes and point clouds and things like that. And what we're discovering is that you can do a hybrid approach where we can store sparse maps in a more broad scale, and we've come up with ways to actually update those with loop closures in multiple sessions and to update them as people come back. And there's semantic segmentation where people actually only care about specific elements within their scene. And so we can create dense reconstruction of those that can be used for the application developer, but not necessarily have the entire scene available to what people are doing. And then we're also looking at things like visual keys. Prove that you're in this space, and then we'll open up the map to you that someone else has scanned. So GPS is not a good way to do that. It's a good way to start. We can figure out what maps we should look at to start there, but GPS can be spoofed, and there's a lot of problems with that. But visually, we can work with the space and look at the features that we can detect in the space to figure out if you're actually in that space and if you sort of have the keys to open that up. But there's so much, we could be talking about this all day. There's a lot of work to be done here.
Yeah, privacy is absolutely going to be one of the biggest issues as we start to scale this data set. So, the reason that Google started their VPS outdoors is because they're probably not legally allowed to own the map that's inside this space, right? Not only do they not want to own it because that puts the liability on them, the issue also becomes that the owner of this space probably also doesn't want them to have it. So if I'm a business, if I have retail, I don't want to give Google my 3D map because now they have my inventory. Now they have my unique designs of how I lay out my store. And ultimately that goes into local search, into advertisements, all these features. And property owners are starting to realize that that's part of their revenue stream. That's part of their digital property layer, right? So you have to push towards this aspect of there's not a data silo where somebody is controlling my data for me. A lot of these property owners, especially some of the larger enterprise companies that we at Fantasmo work with, are very concerned with we want to have the data on our servers. It's on-premise data. It's our data control. It's our data to provide access to.
Okay, great. We're gonna leave it there, but Evan, we have time for a couple questions. Yeah, so we have time for a couple questions. If anyone has one, we have a couple mics. Just raise your hand and shoot away.
Hey, fantastic panel. I'm Jacob from Samsung Next. I was wondering if you could speak to the importance of stitching together different pieces of this map. So if I'm in one location and I'm going to go somewhere else nearby very quickly, how important is it for my device to know what else is around me? Or is it just relocalizing over and over again based on what it sees?
So for us, it's more just relocalization. It's actually a pretty efficient operation we can do CPU-wise, so we can actually relocalize constantly. One of the tricks with that, though, is you're looking at the broader the scope of information, the slower it will be. And we know from our early testing, at least, if we need to relocalize within 1 to 2 seconds, or it's too slow for consumers to be interested. And so that's an area of optimization that we continue to sort of drive on.
Hi, this is a question for Fantasmo. And how are you guys dealing with the whole map and DNS concept, where you'll have content in the physical world, and how would we sort of deal with that and make sure it's the right people are accessing it?
Yeah, so currently it's a model around providing the storage element in a decentralized fashion and providing this location DNS, and that's where you store. Essentially, if I want to look up, the data for this spot, I'm going to query geospatially, and then the owner gets to decide how that is resolved. So I'm going to resolve it to my own private servers. I'm going to resolve it to my cloud storage, wherever that might be. And this is also where the access is controlled as well.
Fantastic panel. I had a question on what is kind of preventing AR from, preventing us from solving some of the fundamental questions that you outlined. Is it the hardware? Is it the complexity of the algorithms to run on the devices? What's preventing us from getting really accurate localization, kind of getting a consistent experience across users? Anyway, so
What's the limiting factor if someone wants to, anyone wants to weigh in?
Because this has been around for about 10 years or 15 years on phones, for example. And I had worked on this, before deep learning, for example, came along. So the question really is, what are the open problems, and what is the main bottleneck that's sort of limiting us? Is it the quality of the sensors on the phones? I mean, what is it?
I think the the combination with ARKit, ARCore, so we can do we can combine monocular imagery with the IMU, has been super important for pose. So tracking the pose is traditionally really hard. And Apple and Google have spent a lot of time on this. So that helps people like us to start to build on top of that. We still have to do bundle adjustment and things like that because poses wander and we have to make corrections to that. But that's been one of the key parts. The second part is how do you identify points over time? And you scan something in the morning and the sun is at this angle. You do it in the afternoon. Now the sun is at this angle, and your contrast points and everything is different. And so what we're working on is using neural networks to be able to work through that to get a better comparison. So the technology is helping. We would all love to have lots and lots of GPUs and battery on the phones. That would make our lives much easier. So that's another challenge, is how do we bundle all of that? And at the end of the day, still have enough GPU left for a game developer to build something on top of our SDK. So there's still challenges to come, but technology is definitely helping us.
Okay, guys, do you have one last word, Ryan? Okay, we're going to have to leave it there. These guys are going to be around later if we have more questions. But thanks a lot to everybody. It was a really interesting conversation.
Great panel. Thank you very much, Josh and panelists.